Hey, everybody. It's Tuesday. That means, oh, no, it's not Tuesday anymore. Just kidding. It's Wednesday, which means live coding. So we get together every Wednesday and Thursday, starting at 14:30 UTC, to talk through Cardano development. Sometimes it's focused on Plutus. Sometimes it's focused on something else. But we're really excited to have a couple of conversations about Plutus specifically today. Sean's here to share an idea he has about Plutus pedagogy, and then we're going to dive deep into some of the stuff that Mix has been able to get Plutus to do, and I'm really excited to have that extended session. So Sean, why don't we start with you? Welcome. It's really good to have started to get to know you over the last few weeks.
Awesome. I've been excited for this all week. So can you guys see my screen okay and everything? Like, and hear me?
I could see the mouse, but it looks like it's just a black background. Is that supposed to be?
No, wait. So let me just figure it out for a second. Um, Sorry about that.
That looks good.
All right, now you see the presentation, okay?
Yep.
Okay, amazing. So basically, I just wanted to present the idea shortly. I had 2 weeks back or so about Plutus puzzles, which I don't know. I talked briefly about in the meeting 2 weeks back, but so I'll just get straight into it. But it's informed by my experience in the PPBL second batch. I think it was the summer 2022. So yeah, let's get into it. So the way I'm thinking about Plutus puzzles is like it could be a library of on-chain puzzles with optional off-chain components. And the idea is like for the PPBL, for example, parts of it were a fairly linear experience where you needed to know the previous modules for you to make progress in the further modules. But like after a while in Plutus, you can start to branch off where you want to specialize just in staking scripts or multi-sig scripts or something like that. And so having this non-linear path encourages that, and it also encourages different paces of learning. So maybe you're good at learning something really fast and you want to make progress in that department, but don't want to struggle with something if you're not able to make consistent progress with it. So you want to have this freedom to do that. So the way I was imagining it, it would be a companion to the PPBL course. So the PPBL course could be kind of like a textbook, and this is like the problem book where you just go to practice the skills you've learned, kind of. And so all these on-chain puzzles would be either on the preview net or the pre-prod testnet to encourage experimentation because there's no financial stake. So people can just freely experiment with datums and redeemers and lose some ADA if they have to in the process and things like that. So like really play with it. So here's like I just listed some potential puzzles that could be part of this Plutus puzzles program. Like it could start off with crafting the correct redeemers to unlock funds from a script address, for example. That could be a simple puzzle which kind of encourages students to go look into how redeemers work. And then slowly they can start locking funds with appropriate datums and unlocking them with the correct redeemers. And then eventually it could be like an escrow contract where one party locks in the funds, maybe another second party needs to sign the transaction to unlock it, and the third party is a beneficiary or something like that. So it can kind of become a group assignment. So you can take it in many different directions. Or like once people get familiar with redeemers and datums, then they can go on to quote unquote more advanced puzzles, like looking at a slightly buggy Plutus validator and trying to make it achieve a certain business logic. So let's say there's like a bugging it that can let anyone unlock the funds or something like that. So how does a student go ahead, take agency and fix that themselves? So it's like trying to get them into the validators once they're comfortable with the redeemers and datums. And then eventually, much further along, maybe they can start making scripts for purposes beyond just payment scripts, like staking or minting, because eventually, like, the mentality should be that a script is just this really, I don't know, elegant way of expressing business logic, and all it's giving you is a Boolean value, either true or false. And what you use that Boolean value for, it's kind of agnostic. So it's like you can use it for unlocking a payment or for staking or for minting. So it's once it's executed on chain, you can really take it many different ways. So maybe ingraining that into students is a nice way to go. And then regression is another part which I really liked about the PPBL, where making progress through the modules felt quite rewarding. And I think that should carry over to Plutus puzzles. So maybe students, as they keep solving increasingly complex puzzles, they can get either non-fungible tokens or fungible ones, depending on how the puzzles are structured. And that kind of gives them some kind of reputation within the Plutus puzzles paradigm, as it were. And then once they have a certain amount of reputation, they can kind of craft their own puzzles for future learners. So the idea being that the progression of a student naturally goes to becoming a teacher, which is kind of a nice, I don't know, story arc, so to say. And it also ensures that the library of puzzles keeps expanding, but doesn't become repetitive, because there is this reputation threshold that you need to reach in order to make new puzzles. And then, yeah, so that's my short presentation. And it's, of course, it needs a ton of refinement and changes, and it probably needs to be crafted hand in hand with the next PPBL course, so that it's really relevant to students who are doing PPBL, but it doesn't repeat the same material. Like, it's kind of covering different ground ideally. So yeah, that's the idea I had. And finally, I just had this, like, so a potential student of Gimbal Labs in the future, maybe they start off as a PPBL participant and they're solving some Plutus puzzles on the side. And then at an intermediate stage, they start creating their own tiny puzzles on Plutus puzzles. And then ideally, eventually they become GPTE contributors and participants. And it's kind of a whole circle that eventually becomes like a virtuous cycle that brings in more people into the Plutus environment. Yeah. So yeah, thanks for listening to me. And I'd love to hear your thoughts.
Wow, man. Thank you. Thank you for sharing. That's really exciting. What's everybody else think?
That would be awesome. That would be really entertaining. Sort of like a Brilliant or something, right? You sort of learn by figuring out the little puzzles and tests they give you.
Exactly.
It's awesome. Yeah, Nelson, I'm on board too. I want to build this. This is incredible. And actually, we're looking at building just an integrated learning management system that we can use for ourselves instead of using Canvas. And to build this kind of functionality natively into that is super exciting. There's so much alignment here. So yeah, I think this is worth a deep dive very soon. I would do a dedicated call to kind of think through specific action steps on this. So let's talk offline about when to have that meeting, but let's do it soon to start moving towards this. Very cool.
Yeah, it's a cool idea. I was going to ask about the possibility of the LMS, because I feel like a good potential here is actually having such a interaction be a lot more WYSIWYG, or at least have a component of that. Just from an accessibility standpoint, I think that makes sense. And then in addition, actually, I think given that, when I first had puzzles, the first thing that came to mind was the potential of narrative, on top of that. because people learn through stories. So, I think there's a potential there to, create, whether it's a bounty or whatnot, to allow folks to actually sort of create different narratives that people can, in a way, solve the puzzle technically while solving a narrative puzzle, right? All the Knives Out, stuff has, really been sort of, front of mind recently. And I think rightfully, because the genre is an interesting one. But yeah, I think yeah, it could definitely apply here. And yeah, thanks for sharing, Sean.
Awesome. Yeah,
Why you
it's
had something?
definitely like 100% agree about the narrative. And I think it's like with this kind of open-ended system, it can also be like students build their own narratives as they go through it, because it's a unique process for each person. And so maybe, and also discover what particular niche within Lucas, although Lucas by itself is a niche right now, but I'm sure there's going to be sub niches that are going, like people are going to specialize specifically in minting scripts or specifically in staking scripts. And I think it's going to be interesting how students navigate that.
It wanted to say, see, this is great. I think it aligns tremendously with what the discussions we have yesterday about the vision of learning based on not using the word learning, but just playing with things. I think it's the best way to learn. And yeah, so yeah, I agree with A, what he was saying about that, as well as Roberto. So yes, it's super good. Thank you so much. I see myself playing with those puzzles to learn more.
Thank you so much.
That's awesome too. Very good.
Yeah.
Yeah, there's some direct ties to the content hierarchy. And Sean, I can catch you up on that. It'll be fun to do a deep dive into this idea and to some LMS playing at the same time. Awesome. Hey, the alignment is growing. Thanks, team. Very cool. Sean, thanks for taking the time to present on that. And thanks also for keeping it brief. This is a great intro, and I'm really excited that we have time now to change to this deep dive. But I know that as I listen to Mix today, I'm going to be thinking in the context of Plutus puzzles and which ones we might be able to pull out of whatever he shows us today. Mix, what's happening? Oh, can you hear us?
Hello, can you?
Hey, gotcha.
Sorry, I was missing. First, hello everyone, and I'm glad that I made it this time.
Yeah.
So, without further ado, allow me to show you how this rabbit hole is deep.
Woo!
So, first, let me share the link of the repo. And I would suggest that please clone that so you can follow me on the code.
Nice.
And then let me share my screen and jump into this. By the way, I don't think today we will see the collateral being spent, because I did some changes to this script and to make it more interesting. I mean, because we'll discover it ourselves. But unfortunately, in some still I couldn't do the coin selection, because what we should do with collateral, we have to build with the raw building the raw transaction, and there are many transactions. There are many input and output inside this transaction. I mean, it wasn't like this, but I added. So now the coin selection is still my math is not all right, but we will discover how we can actually consume that and how we can overcome some of the issue. But first, let me start with the whole idea. What the hell is this actually is, and what's today we are going to talk. So first, let me show you a diagram, which is roughly can explain what is going on. And for those who wants to know what is this, it's an extension that use Draw.io. The Draw.io is a website to build and create different sort of diagram, and there's an extension that can implement that. You can use it and export it as SVG and use it in your README and so on. So the idea is we have a developer team, and they decided to have a token for their project. But they don't want to go with the vesting style of tokenomic and distribution. And for those who doesn't know, vesting means you are seeing that in many areas that the founder will mint the whole token, put it inside the wallets, let's call it treasury or something, or even a smart contract, and based on the time and several or some conditions, they are allowed to redeem and retrieve their share of the token from that. So some project, for example, Indigo, they do it with multi-sig. Multi-sig is a native script which has several keys inside it, and they are coming together for, as I think know it correctly, for eight times, and in each time they will unlock some amount of that token. Sure, it can be same for anyone wants to retrieve that, but I mean, there are other ways to actually handle in this case, not just vesting. And I mean, what I said that is maybe is a very vague idea about vesting and how to retrieve that. But today I'm going to show you another approach to do that. And actually, as we talked with A and other folks last week, we can expand this design pattern, this idea to other sort of stuff, maybe NFT project, authentication token, and even I hope after this presentation we can discuss about that, maybe this approach to a tokenomic can eliminate and mitigate many regulation issue that a project might face because of how a token can be retrieved. I mean, the process of that is quite different than Western style. So for simplest form of the contract, I wanted to show you. I mean, we could go higher and with more complexity, but unfortunately, we don't have that much time for this. I mean, so let's focus on this. So I'm considering that there are two developers, and they want to retrieve their token. But in this case, actually, they are going to mint that token. And they are going to mint that token based on data. And that data should tell them that when they can mint, how much they can mint, what is the total of the amount they can mint, who are the beneficiary, and so on. We can hard code this stuff inside a smart contract for sure, but some of the data we cannot hard code that. For example, if a first developer comes and retrieve his amount, and in this case we assume there is 2 phases, but we can expand that to 4 phases. Like in 2 occurrence, they will come and retrieve their token. So in each time, the state of that situation must get updated. So the second person or any other person or a whole blockchain, and they can know that this action happened. So if we go with all the contract parameter, we cannot update the contract. So we have to use information we can we can rely on and update it. One is redeemer. Sure, we can use that, but the redeemer is possible to get manipulated or get crafted by anyone. But Datum also has same, I mean, maybe same issue too. But one thing that about datum is once you build and once you put that datum inside the UTXO, you can put some certain situation, a certain condition, then that datum can get updated or consumed or even get destroyed. So in this case, especially, we are using inline datum as a reference data to regulate and manage these retrieval and minting of that token for this developer. And we are going to see that. But one thing is, as you guys know, minting contract, they do not have access to data. So now there is an issue that how we can create a contract that can access to the datum and incoming datum, by the way, not outgoing. The minting contract can have access to outgoing, to the output datum, but not incoming and not input. And we want input datum because we want to rely on that and we want to update that a specific UTXO and until the end of all this process. So the idea is using this minting contract beside of another contract, which is spending, and interlinking this contract to each other. So not only this contract can recognize each other, but they will work with each other too. So based on their inside moving parts, which is normally a redeemer, the validation happen. So it's not the validation based on just minting or just based on the spending. It would be both of them. It's like a two contract, I mean, it is like a one contract. I mean, they should act as a one contract. But since, as you know, that inside Cardano, inside the Plutus, we have 4 category of contract, which is one of spending, another is minting, another is withdraw and certifying, which are for staking stuff. We cannot use a spending contract to act as a minting or using minting contract act as a spending. Although about the minting, I have some idea. I haven't go through that. Maybe we'll break some stuff and I will come back to you to how we can use minting contract for spending. I mean, in some very interesting data, sorry, interesting way. But anyway, for now, we don't have that. So now we have to somehow act together. After Plutus version 2 upgrade, we got something called TX Info Redeemers, and that means if I bring in the whole library of the Haddock for Plutus library, and if we go for, I mean, I think it would be on top that for Ledger version, Plutus version 2 context, which will be this guy. We see that we have something called TX Info Redeemers. So based on this, by functionality of this, this is just the data inside the transaction, we can interconnect these contracts to each other and use them. So what is this? What is this actually? When we say it's map of something, it's actually a list, and this will be the key, and this will be, I mean, the second part will be the value. So in order to get the second redeemer, we need to just do some functions with the list and extract that and use it inside of a spending contract. But before going to inside the contract and show you how this function written and how it works, let me go through this process again. So if you have any question, then we can jump into the code. So we are assuming the whole process, at least for first player, this is exactly for second player too. That first player after the contract, all of them get compiled, and we will go through at how to compile it, what are the sequence and the order of compiling and all the files we need, data redeemer. But let's assume that we've done that, and the first developer and those guys done that. They will mint Genesis token, and by Genesis it will be first token from the token that they are going to get in future, and on top of that token, and which will be on UTXO, and on top of the UTXO, it would be better terminology, we will insert a datum, and inside that datum, we are specifying some fields about the date of redeeming, about the addresses, and we will go through that, what information there. So first developer, let's imagine it's the first developer. It can be anyone. Just for the sake of simplicity, I didn't go through so many conditions that who is going to mint this, but you can imagine that there can be many conditions that who is going to under what condition this Genesis token should be minted. But anyway, let's say that first developer will use Genesis mint redeemer, which we define that, and mint Genesis token by using the regulator smart contract. And regulator is the minting contract. And as you can see, I explained a little bit about some of the points about this, what's going on, what will happen inside this. That the line data for UTXO that is going for distro smart contract, which I short form of distribution smart contract, must be same as regular regulator smart contract parameter. So what I did here is I put all the information that's going to be inside the inline datum, in this case, as a contract parameter of regulator, as a minting one. So once we want to mint this Genesis token, we will compare these two data. We will compare the contract parameters and the datum. And if they are same, if everything is fine, then we will send that UTXO to the next contract. And in order to make sure that we are sending to actual and correct contract, at the same time, we will make sure that when we are going to use this minting contract, inside that transaction, the distro contract also present and also exists in that, we will need to use the validator hash of distro contract. So a hash of this distro contract would be, again, a parameter of a contract parameter of this regulator. So now maybe you are seeing that these contracts are getting to start to connect to each other, one by one. So first, we are going with validator hash, which is a contract parameter for regulator. And then we are making sure that this minting contract will happen. There are conditions that we will see in distro contract, that the distro contract can be sure that the minting contract that is happening inside beside this contract is actual regulator. So there is no other minting contract, so they cannot use any other. So these two contracts must verify each other first, and then for the next step, they will go inside themselves and those moving part and the functionality, and then validate each other and validate that UTXO and the minting process. So as I mentioned here, that first developer address and second developer and many other information should be inside the parameter, and we will see it inside the compiler file. And then we will send, if everything is fine, we will send that UTXO with that datum to distro contract, distro smart contract. So let's assume that the time has come and the first developer wants to claim, redeem, whatever you can call in the first phase or phase 1. So he's going to use first redeemer action. This redeemer is distro redeemer. So this first we are somehow like we are ringing the distro contract door, and then there will be some validation which we are going to see, and if it is happening, if it is okay, then the process of validating that datum, that inline datum happening, and then by using that TX-info redeemer, if you remember, we are using the regulator redeemer inside distro. So we are calling, not just calling them, we are actually implementing the whole structure of minting contract redeemer inside distro. And sure, there will be some, I mean, we'll see that, again, as I said before, that is this the correct minting contract? Is this the same or not? I mean, we will check that too. I mean, because we have to make sure that this distro contract getting redeemer, but is this the correct redeemer from the correct contract? Maybe there are 2 or 3. Maybe you have planned that you want to put 4 contracts in the one transaction, and maybe there are 2 minting, 1 withdraw, and 1 spending, or even 2 spending, 2 minting. So you have to make sure that your contract is actually seeing or understand the correct contract, correct smart contract, and correct redeemer. And we've done that, and we will see it. And based on the regulator redeemer, we see that okay, the address is okay, the address of first developer is okay, and then we will check that the distro contract is present inside the transaction. So now, after we make sure that distro is okay with the regulator contract, now we have to make sure the regulator is okay with this distro contract too. So now it's like, I don't know if you know that there is a concept inside the TCP/IP and the network about 3-way handshake, which is a somehow a connection of 2 devices. So the first one sent a data, and then the second device acknowledged that, and after acknowledging, then the first device again will sign, will synchronize, not sign. I mean, it's synchronize. So this is something like this. So first, distro contract will make sure the regulator is okay. So we will send that. Regulator acknowledge that by that function that he shows that, yeah, I have the redeemer. And that function shows that if this contract doesn't have redeemer, or if, let's say, it doesn't acknowledge the process, it will throw an error. Let's say like no redeemer. We will try it together and we'll see that error. And then after getting that, by this, distro contract is, as I said, it saying that, okay, I'm now synchronizing my redeemer and mine process with you. So that's the thing that we are this interconnecting with these 2 contracts with each other. And then we use again, by using the distro contract, distro contract redeemer, because we want to specify this is the phase 1. We will go through the distro contract validation. So now the validation happening inside distro contract is happening with 2 redeemer and 1 datum. And actually, it's not just 1 datum, it is 2 datum. 1 is input, 1 is output. And we are, as we can see, we will make sure that the output will get updated in very deterministic manner. So it cannot be anything else. So, and sure, we will check that the currency policy of a regulator is correct. And then after this, we will, we will send the token will send the Genesis token again to the distro contract, but with updated pattern. So the next step is just similar to the upper stage, but this is for phase 2. I mean, but I just didn't update that still. So there's still a ready-made is phase 1, but is actually phase 2. So everything should be same for phase 2, except we will see that we can change the number of tokens. Like, for example, in phase 1, the person has to mint 10,000 token, and in phase 2, 20,000. So in the total is 30,000. So we can decide that and show that the date is different. But I managed to write a condition that if first developer didn't come to retrieve at phase 1, still he can come at phase 2 and retrieve saved amount, save the previous amount too. So that it would be like total. And how the contract can validate that, and if we will see how a contract can prove that history happened or didn't happen. That would be cool. And again, I hope this will open some idea how to use Datum and Ready-made together. So before jump into the code, guys, do you have any question or something?
This is really thoughtful, and thanks for taking us through the diagram first. It really helps.
Thank you. Yeah, I mean, I'm sorry again, this diagram even is not clear as much as possible, but yeah, I tried. I hope I will.
I was actually laughing about, yeah, like the choices of what shapes do we use to represent each of these things, right? You just gotta make it up as you go along, baby. Good.
Yeah. So if you guys don't have question, or as people always say, that if you don't have question, it means only two things: that you understand everything or you didn't understand anything. So I consider maybe there is a third option. I don't know. So you are waiting to just state your ground that, okay, I'm done with this presentation. So anyway, let's jump to the first contract regulator. Okay, Sean, go ahead.
Actually, one question I had is like, how much of the same overlapping logic will have to be in all of the contracts, or will there be no overlapping same duplicated logic?
In this design pattern, not that much. Actually, for example, here, for example, the first developer must sign the transaction. Well, if you, I'm sure you guys we know that in many conditions or many contracts, this is the it's like a common and a most common condition that's this transaction must be signed by the person who is creating that transaction as a user, but here's the first developer. But we can't, I mean, like now, for example, now we have the same function inside both contracts. And exactly, specifically, I put this, as you can see, that first developer address again is a parameter of the regulator, the minting contract redeemer. So I can use that information to again say that, hey, first developer, you need to sign that transaction. But as you can see, this is actually pointless. So why we should do that? When we can put this first developer address as a contract parameter, which we put there, I mean, inside the data type, inside we can see as a regulator params, which stands for contract parameter. we put that the developer team address must be there. So first developer, second developer, and so on. We can have 10 developer. Their address must be as a contract parameter. So, and when we are making sure all these contracts see each other, for example, this function is distro smart contract present. So why having exactly same condition or same functionality for inside both contract? And therefore, not only that, I purposefully put this, and then there are different contracts, same contract. As you can see, I created a normal contract, but a smaller. I consider this bigger because of there are this thing, there are many comparison which we can a smaller and make them a smaller. And also about the data type, it has to be changed. So, and there is another one, which is a compact version, and we are going to see why we go with the compact version. You can see what there is very smaller. And for the distro contracts, same thing happened, that I created a normal contract, normal big, and this contract is actually type 1, the type, the datum and the ready-made is there, but a normal and a small, we are managed to use the lower type of Bluetooth built-in data, and how do we do that and why we do that, and we'll talk about that. And sure, there is as I said, it's a nice version. I mean, I consider pattern guard. This is a style of let me a little bit zoom it so you guys can see it better. This style of using pipe, this style is called pattern guarding. So exactly same with going with the case and the case condition, like case of this, and then going with the pattern. But it just looked nice. But why it is not just nice? Because as we will see it, it's actually quite expensive in just execution, memory execution, CPU, and even the size. But interestingly, it's much safer and secure, and we will talk about that. But anyway, about the pattern of this contract, we should think these two contracts, even maybe it's 4 contracts, as a one body. So when we want to make a contract or this transaction as sufficient as possible, we shouldn't, as Sean said, that we shouldn't overdo or duplicate same thing. But maybe in some manner we have to take that, we have to do it. Maybe we will need that because of, for example, there is 3 contracts. And this stuff happening inside minting contract, and we don't need the same functionality in second contract, but maybe in third contract we need it. So the second contract will actually route that functionality and that information. Let's see second address. For example, in the first contract, we want this address of first developer just for signature, nothing else. For second contract, we don't need that much. We are just checking with inline data and so on. But there is a third contract. I mean, there is no this case, but imagine. And inside that third contract, we want to make sure, does the UTXO, these tokens, this output goes to exactly first developer address or not? Since we didn't want to put this information in data, that's a business decision. You can go with any other decision. We can pass this redeemer, pass this information to third contract. And then we will use the first developer address to just check in that did this happen, like this TX in output, did that output goes to the first developer or not. So this completely is up to the design pattern, that how you want to route this information or not, and how much would be the expensive. So yeah, I mean, there are many things, but here I just for the as I thought, like you, Sean, that we shouldn't do the same thing again. This first developer address is the one example, and if we go with the normal small contract, we can see that the developer redeemer first developer action doesn't have that first dev address anymore, and just it's use it's built in its contract parameter to sign off, and inside the distro contract we don't care about the address of first developer. I mean, we are considering, we are assuming the first developer is not a stupid person. He's not wants to scam himself, like changing the staking part of his address or send it to another person, not to himself. He can do whatever he wants. If he is stupid to lose his, okay, but if you can make sure that, sure, you can do that. But at least in this case, we didn't care how that UTXO for carrying the minted token, which we are going to see inside some bash script that's created, what the destination would be. We didn't decide on that. Answer this. We didn't care about that. We didn't create a function, but sure, there is function for that. It's easy to handle that case. So yeah, I mean, if you have guys any question, but please ask. So, I mean, for the first now, this that contract, the regulator contract, has several conditions. The first one is Genesis mint, as we talk about, that we want to mint the Genesis token. And that Genesis token is going to hold the reference data. That data is the most important data. And actually, by this, we can show to the whole community and all blockchain that what's going on. I mean, how transparent the whole process is. They can see who's going to get what. We can put any information in that. So if we look at in the data type, the data type of that datum, I actually imported the datum from distro contract. So instead of defining again inside the regulator data type and inside that, like, because again, minting contract doesn't have data. As you can see, it's parameter. This is the redeemer, and this is the script context. So I just imported that and using them for getting the output data. So here by this function get tx out inline datum, which is just the job is doing to get the tx out datum, and if, and again, these, as you can see, these are as pattern. It's just for, like, I wanted to your eyes see another way of writing a case, because all of this is case, and as you can see, it's validation. Validation is just if and then and else. So this is just a case. So we are saying if the output of tx out tx output function, we are giving it the tx, we are giving it that transaction, and let me, for sake of simplicity, just put in this equal here. If the output is this guy, this pattern, and tx output datum, if we look at, has 3 output. It has 3 output, and sure, it is output datum, but output datum has 3 different output. It can be no output datum. There is no datum. It's just a hash, datum hash, which stands for the normal datum hash and embedded datum. And this guy, which is the new one for Protus version 2, which means inline datum. And we want inline datum, not the embedded. For this case, you can go, if you want for datum hash, you can go with, but for the sake of simplicity, we can go with this. And then if it is, then the result of that, which is the inline, I mean, I call this is the datum, inline datum. this output again. Let me again tell that we have two datum in a normal transaction. One of them is incoming, one of them is outgoing, one of them is coming from the input UTXO, one of them is coming from output UTXO. This is from output, this is from TX out. So I'm getting the inline datum of TX out, and by this guy, by using this type application and unsafe from built-in data, I'm deserialized to the distro datum structure, distro datum data. And then if I get that, and if this datum has this pattern, has all of these stuff, all of these are placeholder of data. And it, as I try to write as much as clear as possible that like first dev phase 2 claim amount, like how much first developer should claim at phase 2, how much for phase, this is for phase 2 and it's for phase 1. And we are putting that data inside the data that did first developer claim at first phase 1 or not. And if he didn't, we can use this for second phase. And we can say that if he didn't, like this is just true and false. This is just true and false, that if it claim it become true, if it not false. And if he didn't, he can claim the both phases at the same time. So you can write same thing for 10 phases. And the beauty of this is, since no one relies on anyone, and since it's not kind of multi-signature, if something happened between these developers, a problem happened or someone losing the key or something, none of them gets affected. They can go ahead with their keys, with their token, and they can be safe. And sure, there will be some problem. For example, again, in Indigo, one developer got its token, and at this very first day, he went and dumped that token to the DEX and dropped the price and affected everyone. So even you can create this condition that if some person can get this amount, and you can write that, but you cannot control that much if someone gets that token. But again, they decided that in next, as I said, they said that 8 times they are gathering and claiming their token. It's like a Western style. And they said that in next time, we will somehow stop him to come and claim his token. So you can see that even all the decentralized stuff and the mindset people have, if something bad happens, they will do some very radical decision. But in this style, that's impossible to happen. So if you decided everything, and if you put all this information in the datum, then until the end of the time for the blockchain, this will be the law. This code will be the law, not the human between the like I like you or like gathering. Because in multisig there are problems to like, we can decide that 9 people out of 10, if they present, they can mint, or 10 people, or 10 out of 10. A lot of issue happen. 5 out of 10, again, another issue. So in any cases, some issue happen. But in this kind of case, sure, it has its drawbacks, but those things doesn't happen. So we are just getting the datum, all these fields, and then here, first, with the first condition, I check that is the token minted correctly, and this function is checking here that by using a function called flatten value. A flatten value gets a value, return a list of triple. So let's just look at that. It should be inside the value package. Value, it should be a value. I can, no, yeah. So at the last line, flatten value. So this function gets a value, and maybe you guys know value is the list of whatever it is inside the UTXO, whether it's ADA, it is token, it's NFT, fungible, not fungible, whatever. It is the total of every stuff inside the one UTXO. Here we call it value. So this guy flatten it. It will take the hammer and gets the poor UTXO as an input, and as an output, we will have this nice list of triple, which the first member of this triple would be currency symbol, and for ADA would be empty, and token name, again for ADA would be empty, and the integer, which is the amount. So for example, in case of ADA, this will look like empty, empty, and let's say 10 ADA. But there will be another one which has what exactly the tokens, like whatever token we have. It would be the second member of this list. So here, instead of giving this guy, this hammer guy, the UTXO value, I just giving TX info meet. What is TX info meet? TX info meet is again a value. So it is a list of stuff inside it, but a list of what exactly? Let's look at it. So as again, it's this TX info, and with these are all field of the transaction. TX info mint is the value minted by this transaction. So what is actually is, if we look at the transaction building, which I'm going to show you here, for this is a transaction building. Let's go with the simpler one. So you can see that there is a switch called mint. So whatever you put front of that, the result would be a value. So this guy will create a value, will create a list, will create a stuff that consists of those currency symbol token. For example, here we have just for Genesis Mint, we have just one. But for the claiming, it is just like 1,000. Again, it is one. So you can see the pattern. Let's say there is two. So you know that two different tokens is going to get minted. So you know that that list would, the member would how many? Maybe you don't know. Here you can easily go with the limitation, like because that the last member, which is the important, I mean the where is this? First, the whole length of this list would be an integer. So you have all the functionality to compare it. And also the result of this guy, this amount of tokens is integer. So you can see that by some calculation, you can very strictly determine how many tokens and how many token amounts, like one, like I call this guy happy token. The name of is happy. How many happy tokens should be minted, but how many tokens inside one transaction is allowed to get minted? Like, can I do this like plus 1,000 something else, like 1,000 SAT token, plus another 10,000 angry token. This guy is very angry, so that's why 10,000. So this, as you can see, this is now a list of pre-member, and this become a value. Now we will talk about this and how these policies talk to each other, but now the value. So one of the transporter of information for you to talk to your contract is actually the value, because by this information, especially the integer I showed you, the currency symbol, and also the token name, you can talk to another contract. You can carry information, and because although this is a spending, although this distro contract is a spending, although this contract cannot mean something, but still this spending contract can see TX info meet. Not just this spending contract. You see that in a script purpose here, we have all these different contracts. All of this contract can see each other information. One of the information that we can rely on it for validation, at least in this case, is the value itself with TX info meet. So what I did here, you are going to see as by limitation of this TX info, I'm actually sending data to the next contract. I said that if this is the as you might get the words from my mouth that I'm just saying all this conditional, like if it is, then it is, if it is. So I say that here, for example, inside the regulator, if that value, that minting is happen inside the list of one member, and again, as I said, again, this pattern is a lot of if. We can consider as if and if and if. And again, well, for sake of simplicity, I just do this. And if this is one member, and this member has this one member has 3 sub-member, currency symbol, token name, and amount. And I just use underscore. I don't care the token name. Although I can care here, like I can put the built-in or contract parameter here that, hey, this token name must be happy token or sad token too. But I said, I don't care. So I just wanted to show that you can neglect that. You can handle a case and you just care about currency symbol. You can handle it here. You just care about the number of integers. You don't care about the currency symbol. You don't care about the token name. You can handle it here, no problem. Or you want to just not handling anything. You don't want to care about the currency symbol and the token name and the number of amount. You know, your user in your NFT project wants to mint whatever he wants. But you want to limit that person to just mint one token per transaction, not several tokens by whatever number, whatever token name in one transaction. So again, this can happen. So I'm just saying that with this limitation, you can, I mean, we will see that in another distro contract that this helped. I mean, I'm checking this TX info inside the distro contract. So by just, I just use a function called onCurrencySymbol, which find this same minting contract currency symbol, which is the hash of that contract, and it will check, does this minting is same as the minting of this. I mean, I'm checking that when this minting happening inside that inside that list here, this happy token guy. Let me remove these guys. There are too many emotion, and you know this transaction cannot handle all this emotion. But okay. So now this happy token consists of 2 information, which inside environment file, you can find out how it was created. And I just say that happy token policy ID and happy token name. Happy token name is just the hex of this guy, which is this guy I put here that you can see. And behind this dot, policy ID is in fact by using this command Cardano CLI transaction policy ID script file and whatever after that, the minting contract, you can get that. So it's just checking that this must happen. So this minting should belong to this guy, belong to the regulator. And then I'm checking the amount should be 1. The token name doesn't matter, whatever. And then I consider every other choice false, which return an error. I can be sure that any possible. So one of the good thing about the handle in this case with pattern is, you know, it's just one simple line. You can handle all the cases. You can be sure. But as we're going to see, it's kind of expensive. So anyway, then the next option would be the value of. And one thing that I'm seeing, and it was a good experience, that for checking that does an token exists inside the UTXO, we will use a function called asset class value of. Normally, this is the case. And again, it's inside here, it's asset class value of. So we will give this guy, again, we will give this value, which as you can see, it's map of currency symbol, a map of token name and integer. So at the end, it will become a triple if you apply function like to this or from this or so on. But then if we give this guy with all this stuff inside it and give an asset class, which consists of the currency symbol and token name, should be a 2-member guy, it will find its amount. And it will give you, if you return the amount. Like I want to, how many, even ADA you can do, if you can do it with this ADA too. Like I'm giving the UTXO, I'm giving the empty as a currency symbol, empty as a token name, and it will return me the exact number of the ADA. That's a way to just get the number of ADA inside one particular UTXO. But if you look at inside this function, asset class value of, we see that it's actually using another function called value of. And value of is of just a lookup. It's just a lookup is a function that's I think it would be inside Prelude. Lookup is function that accept a map with key and value, and it will return to you the key. So it would be look up. I think it would be inside the Prelude. Or no, it should be inside the map. Yeah, let me look at in Plutus map, address map. No. Yeah, associate Plutus TX associate map inside this guy, which has all the stuff related to map, and we are using a lot of map. And the K stands for key and V stands for value, but this value is not that value. We know that. This is a very smaller value. It's just you know, the poor value. That guy is the guy that's get the hammer. This is different. Is a safe one. But anyway, the lookup accept a map and just return the value, not the key. So we are saying that, hey, find based on this key, give me the value. And inside this asset class of, we see that we use the value of, and what is the key? The key is currency symbol, and the value is token name. And it will return the integer. I mean, it shows you see that there is another lookup, because as if you guys remember, the value has actually, it's like 2-dimensional map. So it's like a map inside map. So that's why there's two. Where is the value? Oh, here. It's a map inside the map. So first, it's find this key. Based on this key, we'll find the token name, and based on the token name, it's find the integer and return that. So I found out that if you want to, if you can just use the value of instead of asset class value of, it is much cheaper. And in some cases, which we want to handle many stuff like currency symbol handling in different condition, token name in different condition, it would be better, because in asset class value of, it will use a data constructor, or is it asset class, to create asset class, and then going through all this functionality of the loop inside the loop. It's a loop. It's lookup. But inside Haskell we don't have that much of loop actually. It's recursion. But anyway, so I'm using value of instead of asset class value of. So I'm feeding with its information. I'm just saying, hey, you should find that same token because it's Genesis and we want to put that, we want to put on an ADA in the output and send that to the distro contract. So I'm giving that value, I'm giving that UTXO, that list of stuff. Then on the second argument, I'm giving again, say, hey, just check out your own currency CB, your own, use your own hash, script hash, and then show happy token name, which is what exactly here? Here it's a contract parameter. It's not data. But it is, I put this, no, sorry, I think, yeah, it is contract parameter. Here we can see, we can check it, is it contract parameter or not? We can see a happy token name is a contract parameter, and we define it into another file called 2JSON. So here, the happy token information is the name is this guy. And interestingly, I remember yesterday someone was saying that you cannot create a token with I don't know, it was A or someone else that with the capital letter. Guess what? It's possible. So maybe not color CLI, but somehow we cheat the system. So you can do it, but and you will see that it works and no problem. But anyway, maybe this actually is, we will see it as a big guy happy token.
What about the underscore? That's okay too?
Yeah, everything works here. So especially I tried, because this I'm going to talk with you guys on this education. I try to put all the questions that personally I can find in my brain inside this. So each piece of information here will raise a question, or what the hell is this, or maybe what the F it is too. I mean, that would be, for me, it would be the great moment that you are saying these words, because you say, yeah, okay, yeah, now this guy first, he saw this situation before, and now he sees something else, and now that's a great moment for this guy to find out and creating new neural pattern inside his brain and solving many issues, many stuff. So yeah, I have a lot of what the hell is this word will come out your beautiful mouse and beautiful brain. So anyway, this token name here, I just defined this inside to JSON, because I'm using, as you can see, this distro datum here to create that inline data, to create that datum. And again here, I use this for the contract parameter. As you can see, everything here is very interconnected. You can check the repo, you can see that what there is going. And with this hyphen, it is at the end, and just defining that it's specifying that this is not the actual contract parameter, this is something else. So here we see that I checked that everything with very constant. So this is built in inside the regulator contract, and this is also built in. You cannot change that. This function will take that. And this is the output TXO, which we got it already from this guy. So if we didn't get that, we will have some error. So we will not reach even this level. And then I'm checking that this happy token is this guy that's inside that. Is this happy token here doesn't have hyphen, which is bad. Let me add hyphen for sake of understanding. So this is from inline datum, and I'm checking, does the inline datum this information or not? So inside the distro contract, I'm getting this information of token that has a contract parameter, but as inside data, because we need to consider that one contract must get compiled first, and then other contract get chained to that. Sure, we like the idea of let's call it a script chain, like top of blockchain, but one script should be as a Genesis chain. So in this case, I'm considering distro contract as a Genesis chain, not even the regulator. I will see that. So because of that, I cannot put the currency symbol of regulator inside distro. But actually, I want the hash of that distro inside the regulator. And with, I here with is distro a smart contract present, I'm checking that. So by just putting these very sensitive, because that's the maybe most important information, that this is the token that those developers are going to mint. If you messed up this, the whole process is gone. And it's a datum. Oh, datum is dangerous. If you consume it, will get destroyed and updating. But you can do that. You can make sure of that. So anyway, I'm just checking that, and then I'm just checking the contract parameter comparing to the counterpart, which is the inline data, which is again outgoing data. That datum that sits inside the output UTXO, which is going to the a smart contract to that guy. So yeah, and you see that this TX out to distro. Here I'm checking that there should be only one UTXO, and that UTXO must go to a smart contract. So even this Genesis cannot do anything else, cannot send that UTXO to someone else, to another wallet, to another contract. That must be sure too. And if we look at to TX out distro, it's again this damn pattern guard. It's kind of look good, by the way. But anyway, I'm just checking and filtering all the TX out address and TX out address, like I mean the UTXO output, those going exit from the transaction, has the address of contract. And by using this function, script hash address, you can create from the smart contract validator hash an actual working address. So you see that if we want to go to send a date, some function or something, sorry, some value or some money to a contract, we will see that as a address. So let's look at, for example, for creating contract reference, there I created a bash script. So for example, for not regulator, the minting, by the way, minting contracts have addresses too. So we can do some cooler stuff with that. But anyway, distro contract. So I'm just checking the node exists, and we will look at the stuff here. But you see that contract address. So this guy is outside, is upchain, but somehow you have to tell this. You have to craft this exactly same thing inside your smart contract. So the function that can help you to do that is script hash address, and just feed the validator hash to it, and it will give it, your contract actually see this. So it will understand, okay, this is the guy. And interestingly, you can add a staking part too, but anyway, I haven't tried that, but let's just, sorry, I'll just forget about the staking button. No, it's a validator hash. There is no staking button. The Cardano blockchain is a proof of work. Anyway, so sorry for that. I know that's create a lot of confusion, but anyway, so yeah, the validator hash with this will create an address. And then it will check, does the output goes to this guy or not? If it doesn't, it will fail. So we want to make sure. And we'll set this, and you see that there should be only one. Again, as I say, it should be a list, and that should be only one. If it is second, if there is a second UTXO, it's go to anywhere else. Doesn't matter anymore. Like even to same contract to UTXO. If by mistake or some bad intention, you cannot do it. If it wants to send, if you want to, or anyone wants to send another UTXO to someone else in the same transaction, you cannot. So you see, I'm just checking. It should be only one UTXO out of this transaction, and it has to go to this guy. And I'm just giving the output, and this output will be the one I'm getting the inline datum. Here I'm just feeding that. And after that, I'm checking that inside this guide, inside that UTXO, do I have this happy token or not? So these are the and that. So this was the first, and we are going to do the Genesis min together right now. Then we will walk through the other guide, because these conditions here, I mean, let me just go through these two, because as you can see, it's a small. Then we can go for distro contract, and we will work what is that. So there are two just ready-made. There is another ready-made. It's just for debugging. You can just remove it, whatever you want. It's just for, it has all the power to do whatever you want. Is the debugger. I'm sure you should remove it when you go for the production level. And then here in the first, the developer action, which is the ready-made, and the parameter is the address, which, okay, we talk as Sean question. We will remove it in the better version of this contract, because we don't need that. But if you want it, sure, you have to make sure that this information inside ready-made, that this first developer is going to provide for redeeming for token, must be authentic. You have to make the integrity and authenticity of that. That's your responsibility. And here, for the simplest case, I did just sake of this, I just check it with the contract parameter of regulator. So I said this inside the ready-made, you can put whatever you want, but it has to be this guy. You cannot do whatever you want. Yeah. So this is just this one, and this is TX signed by, and there is a better function for doing the TX signed by. Actually, there is better function to handle that, and I hope in the we have a module for pull-based project learning about optimization. We'll talk to many of these functions that you are seeing as a normal function. It can be written better, and how you can optimize it, and we will go through it. But anyway, this is a CS site. It's just this guy should sign. And is distro smart contract present? And is distro smart contract present is kind of exactly similar to TX out to distro, but I'm just checking for input. But this is not the input of Genesis. This is the input when the distro contract come to the transaction or any other contract. So this guy, I'm checking the input, and the input would be what exactly? The input of this guy, the I, is this guy, the output that's went from the Genesis min transaction. So from one UTXO was produced and left that Genesis min transaction, came to the distro contract address, and now for the validation and minting and so on, now that UTXO has the role of input and as data. So I'm just by checking this, that does the input coming from the smart contract, actually I'm checking that the contract itself present inside the transaction or not. So the point here is, if you want to check that your contract present, since we are inside the blockchain that use UTXO for everything, you can use UTXO to verification of existence of contract too. If you have 4 different contracts, you should have this mindset, okay, now I have to check what 4 different inputs, 4 different UTXO.
So would you do that is like, okay, if you have 3 or 4 contracts, I mean, you could make these checks. This could be bi-directional in every contract you write.
Maybe not bi-directional. Bi-directional. Because in order to put input inside TX info list, because TX info input is just a list. James, right. You know it. Right, in order to do that, you have to expand that. You have to execute that contract. you have to use that UTXO. So let's say
Okay.
you might say that, okay, I think that maybe your point, maybe I mistook it actually, misunderstood it too, that maybe someone else wants to use a contract but doesn't want to spend a UTXO from that contract. That cannot happen. That cannot happen. Because we are in UTXO model, in order to bring a contract to the game, that contract must bring something to the game. And that is the UTXO.
Right.
It's
Right.
UTXO. And when it's bring that, it has to get spent. So there should be input and output. So you can try that with some transaction building here. So like with this bash script, one of them, just put another UTXO, but don't spend it. Let's just put as an input TX in. No TX out about that specific UTXO. It doesn't pick up that. It won't go inside TX info inputs. So in TX info input, you can make sure that every information it is inside that, in TX output too, that these are the, let's say, the bet, or let's say it's, someone wants to play a game, like a gambling. I mean, what they call that money brings to the table, forgot that. So
Yeah, table stakes.
yeah, that's the one. And thankfully, Bluetooth has a Cardano protocol that makes sure this happen and deterministic. There is no other any way, at least for now. Maybe someone broke the whole blockchain that can insert a input inside this list that actually is not getting spent. It's just a fake UTX or fake money or whatever. But for now, you are sure, you should be sure, you can be sure, all of these verbs that you can use that I can be sure that inside this list, I can trust this guy. So if you want to use a contract as a validator, maybe 4 contract, all of them, you are trusting them, you are trusting the functionality and what they bring. So they have to bring something too. And then this concept of royalty might come. So if the contract comes into the play of that game inside this transaction table, he brings a UTXO. That UTXO gets spent, and he brings a value. So that value is not the value what holds that UTXO. That doesn't matter. That UTXO may be 2 ADA, 10 ADA, that doesn't matter. The value that contract UTXO bring it is the validation functionality. So if you might want to pay that. So when the input UTXO, for example, is 2 ADA for this contract, for the first contract, for the output, it can be 4 ADA. So you are paying to that contract that, hey, thank you for coming for validating to help him validation of that. So this can happen. That 4 contract come in with each of them 2 ADA, and 3 of them doesn't belong to you, and you need to pay that. You can put all the functionality inside the contract, or it should be 2 ADA or whatever, like as a royalty, as a payment. And then the output TXO, which goes to this list, TX info out. We can check and trust that we can check all the number. That 3 UTXO should be each of them 4 ADA. The transaction builder is paying each of these 3 contract 2 ADA because of the value, the validation, the functionality they brought to the table. And 1 contract just 2 ADA. So input 2 ADA, output 2 ADA. The just transaction hash would change. I mean, the UTXO ID and so on. So yeah, this can happen, at least right now. But maybe we can use something like not a reference script, something like a witness script. So a script can be a witness, but you don't need to pay that. But at least for now, you have to pay for work that's happening. Sure, maybe they don't care. I mean, they can. You can have, a nice, good charity guy a script and he can come to your table, give you money, or I don't know, do something free for you. That can happen. That can be actually a case that some script have royalty, but there you can be sure, oh, this script come from MLab, or they are good. It's very efficient. For example, there is two scripts doing exactly the same thing, but one script written in Plutarch, therefore it's much cheaper, but another written in Plutus, for example. So it's expensive. The Plutus one is free. You don't need to pay to that guy. But the Plutarch art is not free, it's 2 And then you consider how much fee I'm going to pay for Plutus. Maybe even to use Plutus, you cannot insert another. Like, let's say that we want to put 4 contract. And if you add this Plutus guy, you cannot add 4th contract. You are limited to 3. So you have to bring this Plutarch guy and you have to pay it. You see, all these idea can happen in all this, but you should consider, I just really want to tell you guys that you can consider a script as a person right now. So right now we have wallets. People are as a wallet, they are doing transaction, they're responsible, they can come, they can get whatever. But with TX-Info Redeemer and with this interlinking all these guys, at least contract, we can, and but also by a function like a script hash address, which create address from a contract, and actually you can fit meeting contract to it. We can fit any contract to it. So this now we are considering a script as an entity too. It's not just a code; it's an entity, and it has we are calling it a smart. Right now, it's not that smart, but maybe in future it would be really smart. We will put AI into that, and this is like 10 million line of code, and it has an address, and it has, you have to pay or you don't need to pay or whatever. So the idea of a smart contract, now as dumb as they are, is I think it's getting much more smarter. So
there's 2 angles that make me feel really interested in this. Like, one, what I hear you saying is that this gives us the ability to gate access even to the use of a given smart contract.
Yeah.
Right. At a simple level.
Yeah.
Right.
That's the whole point of a smart contract.
Well, the point of a smart contract is to gate access to tokens at that smart contract.
No, my dear James.
Okay.
The point of a smart contract is offering its functionality, its validation.
Offering its
One of them can be accessed to a token. So now that's the mindset I like you guys.
So that's exactly what we're developing right here, right? So at a very basic level, at the dumbest possible level, a contract gates access to the UTXOs in its own contract. What you are giving to us now is the ability to gate access to given validation logic. Am I saying that right?
In my opinion, the basic you are saying is not the basic.
Okay.
Is actually one of the byproduct of a smart contract. The functionality, we used to do that. In Protus version 1, we didn't have this. We didn't have TX-Info. We didn't have this guy. That's why what you said is absolutely correct about Plutus version 1. And that one of the reasons that I was mistaken to neglect that. We don't need to talk about Plutus version 1. We don't need Plutus version 1. Let's go over neo technology. I couldn't be much more wrong about this. And no, we should talk about Plutus version 1 and Plutus version 2, because now that's not just that it's okay, it's cheaper. No.
Yeah.
What we are discovering right now is the mindset has changed fundamentally. The Plutus version 1 whole purpose was just access to the token, access to the UTXO. No. But now, Plutus script in Plutus version 2, they're offering more value. They're offering not just accessing or locking something, but they are offering what they do, what happening inside them as well. And
And so you kind of
use
extract those partial, and I recognize, right, what I said is wrong just because it even ignores minting and credentialing and all that. But the point is, what you're saying now is now we have a greater ability to access some subset of the embedded functionality of
yeah, some
of
or
some
all.
validator.
It's
Yeah.
depend on
Right.
the offerer, or the person who's offering and the person who's get the offer, which functionality they offer and which functionality they do not. For example, in here, the minting contract say, hey, I will make sure that the first developer sign the transaction. So distro, don't worry about it. I'm giving this functionality to you.
And because, yeah, if this validator passed, then we know that we can just take for granted that all of that already happened and we don't have to check again in some other validator. And that's the point I really want to make, is that, yes, like what we are really understanding is that if we use the term DApp, decentralized application, or just any Plutus application, what that really consists of is a set of Plutus validators, and it's essential for each of them to know what's going on with the other ones. And so like so what I see in this code right here is this ability, if, for example, if we're unlocking from two contracts at the same time, that it's unlocking from one can be required by the validation logic of another. And then, of course, we often, one of the trivial checks that I use all the time is I want to make sure that this, if I'm unlocking from this contract, it sends to some other one. But that's just the beginning. There's so much more that we can be checking on, as I'm seeing right here.
Here, for the simplest case, I check that the same UTXO come back to the same contract, distro.
Right.
That's the simplest one.
That's
But we can make sure to go, as you guys saw, that inside the distro, inside the regulator, I made sure there should be only one output, and it has to go to this contract address.
Right.
Same thing can be happening inside distro contract, inside the third contract, fourth contract, and so on. Yeah. So the UTXO, what I again want to guys think as a UTXO as a truck, which consists of not just value, but data, not just datum, but the condition, the state of that UTXO, and not just by datum, no. Transaction hash, any information inside that UTXO, the transaction hash, the transaction ID, the index of that, the number of ADA, the token, how much all of these right now are data actually. Right. Maybe we call them metadata. Let's call them.
So for example, for validator A to validate, we can require that validator B has spent this specific amount, has spent this much, or it includes this or that token, right? And that's where that makes possible real applications, right? And then apply that to minting too. For minting to happen, we must guarantee that this was spent from here or that was sent to there.
Yeah, one of the main thing that actually, you James, you told me that let's talk about TX info redeemer, because in my project that I work in AQL, I'm using this, but it's different manner, and I hope one day I can show you that there are 8 contracts. I have in AQL 8 different contracts. 3 of them are native contracts. So even native contract can come to the play. Right. It's not just a smart contract. Sure, they are stupid, maybe they are dumb, but they can offer the same thing as James, you say, unlocking and accessing, and removing and whatever. It is just access. I want that access that's enough from you at native script. You are simple and that's all.
Right.
But I have 5 different contracts and each of them comes. For example, in dispute, I didn't want to write a dispute contract because what I was thinking about this process, what actually we can achieve with this smart contract, we can have our custody of UTXO. We do not need to give that custody of UTXO. What we have, what money, anything we have to anyone. All of this contract can come, and this UTXO can go to this process in an absolutely non-custodial way and do the same functionality. That's right now in Porto's version 1, we were doing it because we were just limited. You want to make sure something happened in escrow. Okay, you have to put this inside this escrow contract, and I have to sign that. And we don't have multi-signature in a smart contract. So sorry, there is a problem, or no, what we should do. So now we don't need that. Now, actually, we might need that. I mean, they have their use cases, but now we can do with non-custodial. So what I was thinking of using this TX info, redeemer and other information was, and actually I use other concept of using the token name as a mean for authentication for non-custodial way of interaction with the escrow. So we can be sure everything is correct if this contract gives its value. If this contract approves this and alongside it. So in one transaction, for example, I have 3 contracts at the same time. 2 of them are minting, 1 of them is spending, and that 2 minting at the same time, they are burning and minting. Mm-hmm. So it's not just minting and burning, they are shaking. And the spending contract is making sure this process of burning and minting happening, and it is the one is happening. So, and this is I think maybe the first thing that my small brain can think about that. Like you guys can really think.
So I was just going to say, on that note, we should probably start wrapping up now. I know that I have a hard stop in 15 minutes.
Okay.
But yeah, so give us a wrap up and maybe some things to explore, because I know you shared the repo right here.
I'm just going to show you what's the process of the distro contract. You can go through all the functionality inside it. If you guys want, sure, we can have another session or different session. We can have different session like on the Sunday or Saturday or Monday. I will be available. We can have that live coding too, or somewhere inside Discord. We can discuss about this and go through this code. But if just I want to show you, so by this datum M, I'm just adding M to have to get different hash of the same contract. So I do not change the function. So just neglect that. So here I have I'm just checking in the pattern of input redeemer is always input, and datum input datum. If this is the one, if this is the one, this pattern happening, this pattern is the one that I'm getting first with the phase 1 claimant token and with minting contract currency symbol. So I'm giving the regulator a smart contract currency symbol and policy hash or whatever you can call that as a parameter to receive redeemer. And then if it is okay, and you might say, oh, you say to redeemer, anyone can change it. Yeah, okay, just bear with me and you'll see what's going on. So, and then I'm again going with another case. And this case is about getting the inline datum of output UTXO, which is going to back to the same contract, the distro contract. So I think you are familiar with what was this. So, and this is again the case stuff. And by the way, Steve, sorry, just I'm going to finish this very quickly, and I'm coming back to you. So this is the inline datum. We talk about that as you guys I think already know. And then we are reaching to the third level, which is I'm getting the redeemer of minting contract here. So this is, as I said, sign act. It is, I'm going with the first acknowledge. Okay, I'm getting the acknowledgement, and then I'm synchronizing with another contract. This can be with another contract, 2 contract, 3 contract. So another point I want to make sure that in one of the contract, or maybe 2 or something, you have to have the idea of synchronization between these contracts. And after the synchronization, which is the serialization and deserialization of the redeemer, we can see that get minting redeemer is actually this guy. And TX info redeemer, as I show you, is a list of tuple, and tuple is, this one is the purpose. By this, we will understand, okay, this is missing contract, spending. We have, we can have several stuff. Like, as I said, in one transaction, we had 2 minting contract. What difference currency symbol? Because this currency symbol is a hash of the same minting contract. So you cannot define this currency symbol. It's built in. So you can't trust this guy. And then it's redeemer, and so on. And then I'm just with the lookup, which we looked at it, what the hell is this? We will search inside this list, finding that. And this CS, what is this CS? Is a parameter. What was that? Is a minting, there's a parameter of the redeemer. You want to say, hey, Ali, still we didn't check this. Anyone can choose. Okay, just bear with me. And then after getting that redeemer, it is a raw redeemer, and we have to destructure it, breaking down with get redeemer. We can check out what this guy is do, and then again rebuilding that with regulator action. And I import this regulator action from the data type of another contract. So somehow, actually, this contract, if you guys want to interact with this contract must have access to each other data type too. So they have to understand each other languages. And one of the languages and one of the rules is a data type. So they have to have import to each other too. They cannot do whatever they want. So yeah, I just, again, I destructure it, break it down, this redeemer, and again, restructure it to this, which now, sure, the regulator contract understand that, but I'm making sure that this distro contract is understand too, because maybe there will be same redeemer, same structure, but with different name or something. You can use it, but if it match, you have to make sure that. So this is the guy of synchronization. Well, this is what I mean synchronization. That I get the redeemer, breaking down, and synchronize with what I have, and then it's answer from built-in data. I get the whole data, and then if I get that, I'm now have access to the regulator redeemer. And now then I can go through all the steps that a spending can do and all the functionality distro contract can bring for regulator, bring for me. So regulator bring his big bro, which is a spending guy. He cannot handle data. Data is, so now this big guy, this big bro solving the issue of handling the data. So now the spending contract, speak to the data, speak to the UTXO, and tell to the regulator, don't worry, I got you here. And the first condition I'm checking here is, does the currency symbol of happy token, which is inside the inline data, and which we checked everything should be intact, deterministic, restrict inside that by contract parameter regulator, and we are sure that we are making sure that. So we are sure that the inline datum is authentic. It is correct. I'm checking that this guy, anyone is making that redeemer for distro, did he provide the correct minting contract or not? There is another option too. You don't need to do this. You can just check this again minting contract parameter with the token, Genesis token inside the UTXO2. But I purposefully use this so you can you can see that you have the option to use data. You can, because you made sure of that data. Because if I use this UTS, oh, I have to check with the state datum, a state token, and that state token, sure, I can rely on that. But no, if you make sure everything happened in Genesis correctly, you can make sure that your Illinois datum is okay. So, and then there are other conditions, and again, this guy happening. Just please, for change, I created other contracts, same version, everything, but with different style, as a normal, small, big, but I hope I will create the README so you can understand this. But the thing is, here, the contract is type 1. So this is type. Therefore, now if you want to compile it, you need to have this guy. But if you want to go to other kind of contract, which actually we made a problem, but unfortunately we didn't have time, but I hope we can have another session so we can discover the issue of this design and how we can solve that. So you have to go with untype. All of these are untype, see the built-in data. Then you need to comment this guy and comment this guy out. And then coming down here and commenting the type version, which is this guy, and then commenting out this one. And again, you have to go to the compiler and commenting this out, commenting this guy. I know this hassle, but I just wanted to show different type of contract that can happen. What are the advantages? Unfortunately, we didn't have the time to go through how we can solve some of the issue we could see. And there are this script for 2JSON, and the sequence is just, let me very quickly show you that if you want to compile this guy, what you should do is first, after going to tabular REPL, and thankfully I use the newest method for the Cabal project. I use a CHAP, which is a standard Cardano Haskell package repository, and I put this. I hope we will have the Bluetooth Essential module. I made the stuff inside the mirror. We can talk about in next session. But anyway, this is very helpful. It's good, and we can talk about that. Anyway, okay. So now I have to again. I do this. Okay, now I'm just going to compile the type 1, the type version of that, and let me just zoom in a little bit. But the process is same. So when you are inside distro compiler, it shows everything's fine. Just type write a script with W and tab, it will find, it will go directly and it will compile. Then load the regulator.compiler. So, oh, sorry, this should be that one. What's the problem?
Regulator, not
yeah,
regulator.
Okay, now I come from there. Let's go to load regulator. Yeah, compiler. Sorry for inconvenience. So now inside the regulator, you will call write a script again to compile the minting, the regulator contract, minting contract. After that, take this hash, this script hash, which is the minting policy, which is the policy ID, which is all the words actually synonym you can see. And you can see the distro contract has just, I automated itself. Just, you don't need to put it directly with this function. It can put inside it, and you can be sure the type is safe, no problem. Happen after getting this hash, come to the 2JSON in regulator, change this happy token currency symbol. And after this, load regulator 2JSON, type main. This will compile all and create all the necessary datum and ready-made you need. And the interesting thing is your minting contract needs ready-made because in the inline, we want that inline data. But anyway, then after this, load distro.to JSON. And then again, call main. And it will again produce all the data already, man. And why we should do that? Because inside the to JSON of distro, we are using this happy token currency symbol too. Okay, so because we are, as you say, distro datum was our basis. You see that happy token name, and I'm importing them from to JSON. So if you change something there, automatically everything will change. So you don't need to worry that you have to change everything. But so that's the process. First, compile the distro contract, then compile the regulator contract by loading this guy. And I hope in some module in future optimizer we will talk about, or maybe we can talk about all of this, and then load the to JSON for regulator. Sorry, take the hash of regulator compiler, go to the to JSON file, change the happy token currency symbol, then load the to JSON, call the main function, and after that, go to load the distro to JSON file, and again, call the main function. And now you are good to go to use the bash
Mix,
script.
I'm really excited to break this down. I mean, what you have prepared today and what you could clearly keep going to do could fill a 10-week course. And so yesterday what we were talking about writing module headings and learning targets for the intro PPBL course. I think a lot of what you're doing here, a really good exercise for a sub team to get together and do would be to go through, write the category headings, write the learning targets for what we're going through, and then even what you just raced through in the last few minutes, like that's an active lesson that somebody can do, right? Here's what you're going to do to run this on your own. So I'm really excited for us to explore that together in the weeks to come. This is such a great starting place. I have to go now. Should I leave you as the host of this meeting so you guys can keep going?
Because I'm pretty sure it will come, because I want to tell some stuff, but
sorry. Well, let's just be aware. Let's really be sure that we're aware of what we are asking of other people's time too. I get it. Yeah, sure. I know you want to keep going, and I really do respect that. I just want to make sure that we're like asking people's permission to keep using their time this far, kind of over the bounds of this meeting. And it might be better to just come up with next steps, give people a chance to digest this for a minute. And then, of course, like it has to be a priority for us to keep going, but let's make sure that we're continuing to keep going in a way that checks where people are at and makes gets us up to date. And that's why I think it's a really good exercise.
We will have all the coming weeks, next Wednesday, and again maybe Sunday, Monday, one day we can talk about that. But I don't want to go through the contract, because I prepare many things like optimization of this contract, going through Plutonomy and introduce you guys with this all this function, but we can talk about later. But I just want to, because you want to test this the sequence of the bash script. It would take just several minutes, but if you guys want to stay and talk about this, please let me know. We can say, and James can gracefully give me the host of this. If you guys want to leave, sure, we can. So just a quick. And after that, we will come back to sleep. There are many things, by the way, in my DM. You can hit me in Discord DM. And sure, all of this material is very introductory. We will go through it, many things and stuff there. You will face many issue. Don't worry, I got to cover. But the thing is, one of the things that you have to do is create wallets. You need to use this bash script to create your wallet. And this bash script actually can create any kind of wallet for you to interact. And as I said, I will talk with this. I will use this script to. I happen to create a gist from this guy, from that. Where is it? Here. So I'm sharing this gist to you guys in chat. You can create all the necessary file for a wallet. Let's go very quickly together how this is and how, I mean, what is this? Let's just make me mkdir a test folder. Inside the test folder, I'm calling the create wallet. And after that, this bash runs and it asks the name. What name? Let's say Adam. I want the name of the wallet. Then it asks for memory. You can go off under that, but in order to work with the Cardano CLI, you cannot go under 9, but you can go 5 or even 7 too. But because that's why I limited that. For example, if you go with 5, you see it will give an error. So yeah, I mean, also this error can help give you a lot of more. So Adam, I go with 24, let's say 24 word. These are the recovery phrases. So you can, I mean, this is just a script for you. You should, maybe you can do it offline if you want to use it on mainnet. You can use same thing for for any chain or any network. But I commented out. You can go to look at inside the script. So the payment address index. So if you see in the eternal, when you go to the receive, you see that there is something called like M 8052 and 8015 and 000. So what are these in coming weeks of the Protus based project learning? We are going to talk about, especially I personally come to talk to you guys about this, that what the hell is this, how you can drive different addresses from same, and how you can drive different accounts. And each of these zero, the second zero is for a staking address for this guy, for a stake guy. And the first one is for payment. And the placeholder can accept around 4 billion, 600 million something different combination of addresses. It's not combination, sorry. It's 4 billion something here. It is 2 power 31 minus 1. It is something like, if I remember correctly. And 2 power 31 minus 1 here. And imagine, and this is just for account 1. This can be like account 1. And then there will be a role. There will be different chain. For right now, we have internal, which you can see that we have external addresses, we have internal chain addresses, we have external addresses not delegated. All of that bash script can create all of that, and we can check that out. And actually, if inside the bash script, or inside that link, I pointed out, but the base idea and all the information are existing inside the repo of Cardano's addresses. Here you can check that out, and you can see all of these commands, what they are doing, what is the purpose, and the naming. I personally choose to make it understandable. You can choose any naming. So okay, now I'm going to just for the normal wallet like Eternal or Nami. Your payment address should be 0. Like the default is the 0, as this is 0001. But we can go with any number. As I said, it can go up to 4 billion something. So I just go with, let's say, 10. And it's showing you the public private key. And you might say that I wanted to talk, maybe in future I'll talk that, hey, private key, I thought it's the key, but it's an address. It's not the key. Your private signing key is an address. And your public signing key is again another address. So how the hell this is an address and how this is signing happening? Again, we will talk about that. Maybe you can go find that by yourself. It would be a very fun thing to do. And after that, script will create payment signing key for working with Cardano CLI and payment verification key. And as you can see, this is payment extended verification key, Shelly ED 250 590 BIP32. So this key complying to all the cryptographic that we are going to see in future, I hope, like with protocol version 8 and with other interoperability chain between. So this verification key is not just bound to one chain. You can use it in different chain too. So that's the whole name of these means. So like all like this accept, this was produced by all the standard BIP32, this. So anyway, then it will ask for you, if you see under the, please enter the stake address index, which is again another one here. For us, that this one is 0, as you can see. Sorry, it is 0, but this one is 2, but it's 0. You can see this. The stake address is 0, and this is the role. And I mean, if it is 1, it is payment. If I remember correctly, it is. If it is 2, it's a stake, and it is. You can go other numbers. Again, you can go all the details. You can know all what the license number are. But anyway, if you want this one, go with the 0. Normally, your for now at this, which you are delegated to one pool and you have to delegate it to that one pool. We do not have partial develop staking. So you have to go with 0 if you want to use it. And then it's usable. You can stake with the column 0. But anyway, this should be 0, but you can choose whatever you want, let's say 100 even, and then done. It will create all the stuff for you, a stake address extended signing key, and a stake address extended signing key public stake and private. This is, they call it private, sometimes they call it child, they call this public, and maybe you want okay, if there's a child, there should be a parent. What is the parent? This is the parent, root parent. And what is this root? This root derived from your recovery phrases. And again, there are blogs that are explaining this. So at the end, you see stake public key hash and the payment public key hash, which you are going to use it inside the smart contract, inside that parameter, and then testnet delegation address, which you can use it. So this is the combination of the index that you are putting. So if we go with another iteration of same script, by the way, this is the simple script. So please be careful. If you run this, it will overwrite everything you already created. Okay, so be warned about that. It will rewrite everything. So if you want, just go with another name for wallet, like Adam 1, Adam 2. So just you can test with that. And I just wanted to, never mind. So after creating this wallet, then how many wallet you need? In this case, I created several wallets. Collateral wallet, which is act as a collateral. And because why I created a separate completely wallet for collateral, because we will have plan, I hope in next session we will do that, to expand the collateral. We create a purposefully failed script and messing around with the execution as a memory execution. So you can see that, how you can lose your collateral. So you can track that inside another wallet easily. But you can go with a very constant UTXO. But anyway, collateral, just said collateral as a wallet name, we saw that. Contract reference, this is going to hold all the contract references. Debugger, first dev, second dev. So in order to create your testing this, just please create exactly same folder and exactly same thing. And with what index doesn't, I mean, it does matter. Why? Because at the end of the day, you need to put this address inside the facet for getting ADA, test ADA. So it is not bound to what index you want to use, but you have to remember or have to use this address. So I really recommend that go with the 00, 0 for payment index and 0 for stake. And then you can import the same stuff here, inside the Eternal wallet. Just add wallet, restore wallet, it's a 24 words, and it's just matter of copy paste. So we saw there is a test. Where is the test? Okay, so another repo. I mean, I have two repo in the same. So anyway, but you can just do that. Let me import another wallet. Let's say collateral. Go to the this guy collateral, the name of wallet dot private recovery phrase, and if you see private, you should keep it safe. Just copy everything, Control copy, come to the wallet, paste it, and automatically Eternal will understand all the word and it will put it there. Don't worry. And I don't care. This is just a wallet test editor. You can use it whatever you want. So yeah, continue. Just set a collateral and password. I said that admin. I mean, what's the Gimbal Labs 1 2 3 4. The most secure password. Yep, that's it. And this one, and save. And you see the number of account inside the same script. You can comment out the index for account. So if you want to go with offline creation of offline wallets for anything, and you want to have a payment wallet without going to any wallet, maybe you think that Eternal wallet collects something from you, maybe, and you can run this script. But in order to have that, you need to have you need to have this Cardano address or Cardano wallet tool. You can, if you have the Cardano, you can have that too. So anyway, then you can create this address in account index, and each account index again can have 4 billion payments and 4 billion stake parts. So each account, and the for account index is again same. You can have at least for the current 4 billion something, 2 power 31 minus 1 different account and under that. So you can imagine from just 20 forward how many stuff you can draw. So you can just do this and roll index for the chain. Check it out. I just use it for 0, and here is index is 0. And here I just say, yeah, it's 1. When we could say 1, it means 0. And after that is going to synchronize, and inside it, you can see exactly the same thing inside. So after creating that, if with this, if you don't want to follow that, go to the environment configuration file. All the constant and paths are there. Check it by yourself. And then after running this stuff, after compilation, run the Genesis Mint. First run all of the reference contract, creation of reference contract. So we can see that just that's a create. First, I recommend to go with the regulator contract reference. So let me zoom. It will create automatically. You don't need to put anything. It will find. You just observe it. You see that everything is done automatically. Just sign, submit it, and then after waiting some time, create distro contract reference to TXO. But at the meantime, you can go with a Genesis Mint until this submission. So, but anyway, you can wait for some time for creation of both. If you get some error, it might be because of this guy. So distro after that Genesis, and after the Genesis, if you mint the Genesis, if everything's fine, you'll go with first dev claim at phase 1, the first test. You can, because of the functionality inside the contract, you can see that you can go directly to the phase 2. Why? Because right now inside the contract, I commented out all the time stuff, but I created another script, the Haskell script, to analyze time with each other. Maybe in another time we can decide. I create this, that how to handle. But this will be another complete subject inside the Bluetooth Essential module that I hope I will go to build it. And how to handle time, what the hell is this, and how to convert this time together. This script can help you to understand that. But for now, just the contract doesn't have the time, so you can free to go. But just you can check that that in the second phase, you can retrieve your the first dev can retrieve, because we checked that inside the contract. So yeah, that's for me. Thank you very much for listening. I'm sorry for so many material. I know your beautiful brains already melted. Part of me, I'm glad that you guys are melted, but you know. So yeah, I mean, there are a lot, and again, I'm going to create and write all the README stuff and diagram, installation, repo guide. So I'm sorry that I didn't have the time, and diagram an example even how to what the hell it is, and you can see that all the output exists here. And yeah, I hope we'll continue on this. I'm sure there is a lot of things to do with this. We can introduce many, and we can introduce other stuff like two spending, and that would be really amazing. Two spending contract at the same time, and you can just throw UTXO at these dogs, and you can see how they fight, and you enjoy that fight of this script over one UTXO. And you can actually, I had this plan that you can somehow determine, and you can see, you can somehow go with the lock that which UTXO you don't know, which UTXO would be the winner of the which script would be the winner of that UTXO. So that would be a fun thing to know, that like, and we will bet on that, you know, like which script will win. I mean, that would be another game too. But anyway, let me stop that, so we can hear some question, and then sure we'll wrap up this session. Again, sorry, take so long. Steve, please go ahead. I'm sorry keeping you long. To
Man, you impress me with your metaphors. Like you've thrown so many at us in the last couple of hours. I'm stunned. You said one thing an hour or so ago that's really rang a bell for me, when you said we could think about these reference scripts as people or as a person.
Yeah, I don't, maybe people, you know, to be honest, maybe people for now, at least they will get offended. And now I really call them an entity. Because
yeah, it's okay.
if you call
That's
them
okay.
entity, it's better. The word is better. If you call the it's a person, he's going to get my job, you know.
No, but here's the thing, you know, like what it did for me is like, well, you know, if we think of them as a person, you know, and like, and they're out there, right?
Yeah, of course, in the traditional,
and they're helpful, right? They can be helpful.
Yeah, high frequency trading. There are the bots that are making money.
I mean, is it not possible then to like crawl the blockchain and look for reference scripts that could be useful for us?
Yeah, Cardano can have an option called contract transaction. It's just very simple. It's a contract that do, and you can say, okay, this is the contract transaction. What if there is a section that the contract can advertise themselves? That is, hey, look at, I handle this transaction with the lowest fee as much as possible, and I'm handling this thing too. So we can crawl that blockchain to find the best suitable contract, and even call that as a query. We don't know what contract are, but we can query like a GraphQL within Dandelion. It can be a service. As I said, a script as a service. And that should be, the blockchain is the database we want, and we can rely on that.
Okay. I got to run, man. Thanks a lot.
Sure, great to see you. Yeah, I mean, in future we will talk about this more. This is the beginning, and I wanted to share this passion with you guys, that now we are seeing this code as something really interesting, not just unlocking. So yeah, I mean, I hope I know that Steve, you will come up with very great fundamental ideas. So yeah, I'm eager to hear you from you. I mean, in future, sure. Take care, man.
Take care.
So hey, go ahead. You're welcome. Sorry, Janti.
No, yeah, go ahead, Janti.
Oh no, me, I was just saying thanks again, Mix. Me too, I'm about to leave in a few minutes.
Great. I will see you in our meeting. I mean, the dev meeting. So take care. Thank you for being here.
I'm sorry, for interruption. Go ahead.
Oh yeah, go ahead. Bye.
No, that's all right. Yeah, Mix, man. Yeah, thanks for all of this. Like, I'm gonna have to rewatch it to be able, to sort of grasp um more of it. But yeah, and thank you, man, for your generous, just sharing your time and explaining stuff. It means a lot. What we're working on here, I think, is has a lot of consequence, with regards to Cardano and just crypto in general. Because yeah, I mean, there's a whole bunch of reasons why I could go into, but I think most people who are already in Cardano kind of know, from a thinking from a security standpoint, they're able to understand that it's not those who move fast and break things who ultimately are going to have built the foundations, right? It's
Yeah,
slow and steady.
exactly.
Yeah, one of the things, like as you're talking about this, like my mind just kind of kept going to like, oh, it would be cool, to think of security, like when you're talking about all the different uh addresses, my mind just kind of kept on going to, okay, how can this be implemented from a user experience standpoint to create the best privacy preserving user experience. And yeah, anyway, long story short, you spoke about the diagram earlier. I'm curious I learned visually. I'm curious to kind of explore it a little bit, and it would be cool to have a conversation with you about it. And
Sure. Please
yeah.
look at it. If you find that there are some problem there, like some confusion or some mistake, please let me know. And I hope I will create other diagram too. But let me be honest with you guys that it is hard for me to conceptualize all of these to something and that you can, because if one diagram is two-dimensional, and as you can, I think maybe you understand that this thing is not two-dimensional, it's absolutely three-dimensional, maybe four, because we have time to, it's four-dimensional. It's not just coming inside one input output. No, it's, and now we have different contracts that's at another dimension, and we have time. So I personally have, at least right now, have a hard time to put this different dimension into one diagram. But if you can help me onto that, and like how should I bring and break down, I would be really grateful.
Enjoy.
Thank you.
Yeah,
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 sure.
absolutely. Yeah, I'll try my best. Yeah, because yeah, it's super super valuable and super important. My last, I suppose, quick question here is, from Equival's standpoint, like how are you balancing, like basically essentially what is contributing so much of your time and energy, giving so much value to the community, how are you managing to balance that with like Equival and
Well, the
yeah.
lot of things that I discovered and I learned here is, it was, I mean, where, and I think it would be working on Equival, because one of the things that Janti, although maybe Janti, I mean, he left, he was my teacher and he invited me to come, and he wrote a score contract already. But one thing that I really grateful from him, that he allowed me to let's say comfortably to discover what I want to do, what I can expand. So the first idea was how to make this escrow contract secure, and the second idea was how I can make sure this contract work as is intended. For example, the input coming to this smart contract, how can I make sure that input is okay? And so if someone, for example, sends some input into the contract, my contract do not get confused, even with the same token inside it, because this escrow, the idea equivalent is not just for ADA, it's for anything that you want. It's for services, it's for NFTs, for token, a stablecoin, whatever you want. It's the P2P. You want service, you want crypto, fiat, whatever. That was the idea. So by exploring slowly, by overcoming this challenge, I gather this knowledge that you are seeing, that I'm really passionate to share with you guys. And still I'm learning, still I'm solving some issues, still by even today I'm learning some things. In my opinion, I'm pretty sure that in Equival I will face some issue that me personally cannot solve it, at least maybe in some manner. But if I share all of these experience with you, one of you might get encouraged and work on that and find something, and maybe you will share with me and we share community too. So sure, in my opinion, this is, at least in my opinion, it's a win-win game. So I'm just, if we talk very cheaply, just, you know, in a standpoint of what I get, what I give, you know, but in higher level, what I personally is, I mean, somehow is giving is what I gave already. I mean, what people already gave me, like James, Jonty, and other, like my 5 first teacher inside first iteration, teacher Adrian, James, Adrian, Piotr, Apple, Karim, and Jonty. These guys were helping me, giving me, and last year in the same time, I didn't know anything about Protos at all. So I somehow, you know, I just giving back some what I was getting, and this is for me. But again, going through the equival process, I face some issues. It's not just sometimes about code. It's just about the design. It's about the business plan. For example, in one time I watched Army of a Spy YouTube channel, and he was criticizing about a non-custodial or custodial way of handling a smart contract of people funds. JP, Data Store, CNFT, DEXs, all of them right now, they are custodial. You have to trust them. What if we can do something non-custodial, but at the same or maybe better functionality? And that again made me think that what if I can create that Equiva as a first non-custodial escrow contract, so you can trust the code. You don't need to trust Equiva. And the first iteration, the first version would be, maybe in the second version, we will create a desktop app. So you don't need even a front end of Equiva to interact with the contract. You just need to have this tool, have the having the node and all sort of thing, and then interact with this contract. So this idea, and when I think about that, sometimes I had to rewrite, you know, for some, it was 2 weeks took me that I had to rewrite everything. As I said, it was 8 contracts. I mean, the 3 of them is not that much, is some very simple condition inside the native script, but the other one I had to rewrite everything just to go with this idea. And then the idea of what if we can introduce proof of work token instead of, you know, I mint, like the equivalent mint the token. We want to have that utility token, DAO token, whatever, any project does that. Then we will put it in some treasury or somewhere, and then we will give it to people. What if we will do it in proof of work and stuff? And what do I mean by that is, what if the equivalent dev team, we will be inside the network, same with the Bitcoin, and we will be same as any member and earn our token. So, well, I mean, how can you apply that scenario into a smart contract? Again, it should be a smart contract. It should be something else. So you might say, can it be possible? Yes, in Ergo, it is like this. Ergo is a proof of work, Ergo is proof of work blockchain, but it is a smart contract. They minted everything inside the one smart contract, and that smart contract is handling all the mining. So it is happening, but I'm thinking about other things. It's not just I mint everything, put it inside a smart contract. If that smart contract get compromised, well, all the token is gone. No, but if that's minting happening by time, by the people, and we talked about that last week. So all these ideas, all these help me, and I'm pretty sure I'm not seeing many things. I'm missing many things in this design business. Maybe it sounds really good, but it is not functional. That's why when I talk to you guys, when I bring this to you, you guys with any background you have, especially if you are not coder, that would be actually better. You can see through this, and you can help me, and you can help all project and Gimbal Lab. So yeah, many things I've considered. So I really think that you guys are helping me too by if I this what I do is helpful for you. So yeah,
It
sorry for
is,
long answer.
dude. No, not at all. Like, it's a really good answer because, yeah. I mean, it's so early, but then at the same time, what we're building now, as I see it, is, there's a lot of value is going to be transacted through the efforts which people are doing now. And yeah, just thinking about like compensation, I've been thinking a lot about tapping into existing models like I mentioned in the past, like the ARM or the Foundry model, where the people who have to who initially don't have that much capital, but they have time to do difficult things, and then later on they're able to then be remunerated um after setting out the architecture of these base primitives, in a way, sort of like from a licensing standpoint. So I've been thinking about how to implement then one of the jigsaw puzzles of this is looking into Switzerland, where royalties aren't taxed. So setting up an entity which then is able to basically custody those funds, and then at a particular point in time, whenever the contributors of those scripts which have been used, and then obviously one of the functions within those scripts would be to pay a tiny
Yeah.
amount. um
Because now
yeah,
we are
basically.
thinking script as an entity, as an active member of the transaction, not just
Yeah,
a very static person just coming doing something. Now we are thinking as an active member. So now we can give role to them.
exactly. And in addition, like the additional things which I think are really interesting and dynamic, as you just said. So far, when people put scripts up, they put a fixed percent of, like,
Yeah, exactly.
pay this. I'm thinking, like, why not actually create a script which figures out supply and demand in a way that can actually tap into a pre-existing formats. Like, if a particular person paid overpaid in the last epoch, that could then factor in either collectively or for the specific individual, and offset that overpayment that they did previously.
Actually, I've done that already in EQL. The fee inside the calculation inside a smart contract is not constant. It's just a there are many calculation fee inside that the function but the information are coming off chain, and I'm accepting as a datum. I'm checking everything is intact, authentic, and everything in datum, but I'm acting as an oracle. I'm giving the contract just to calculate. Like, for example, we are introducing the concept of tire, like diamond. Some person works like with a higher percent of transaction, the number, lesser fee. We don't need to do that. We will just give these numbers, just numbers with different number to the smart contract, and that smart contract, I hope I can show you one day, will do all the calculation, and it will be deterministic. The calculation, you can't trust that because it's math, it's provable. But the number, you don't need that. You can just give the number, datum, redeemer, another script, doesn't matter. So that's why when I was thinking about this, I reached to this level. I was very happy to extract all these constant numbers from the contract parameter. You know, the contract parameter right now, maybe it's just 2, 3. This escrow contract is really big. You should see that it's really big. It has 9 different redeemer and so many stuff. When I didn't go with the optimization for the reference script, it reached around 178 for reference. It didn't accept the transaction failed. It didn't go. I mean, it was past around 40 kilobyte, but I reduced and with some design pattern. One of the good thing about the different script is you can break down your script to different. So if your script is too big, you can have the different script and you can bring them when they are necessary to be in one transaction. But anyway, after removing that, now I could see that, okay, my smart contract is like an accountant, it's an entity. I'm going to see him give these numbers, and I trust the code, and then I can get it. Not just me, anyone. And again, as I said, it is non-custodial. What is happening there is just I am a witness. The equivalent admin is just a witness that the transaction, especially the data, the transition of the state is correct and authentic. That's all. Nothing going to like every piece of the Lovelace already have. You might say, how did you manage with the percentage? I really like maybe in PBL or maybe in future, I can show how you can convert a normal percentage, because you cannot do that percentage normally as a smart contract. That's kind of flexible, but no, there is a way to go with the constant percentage. But the calculation of percentage happen inside a smart contract, but you can have different percent and your smart contract doesn't fail. So the math existed. So I thankfully I figured out the math. The math there is a function you guys can use that when we open source this code, and you guys can use the functionality, and then just a royalty, anything. You don't need to put any number anymore in as a parameter. Everything can be flexible, and you can see all the how they are interacted with each other. So
That's super awesome. Yeah. I'm working on some tax stuff. Basically I'm trying to build out a way for crypto tax, a native way to pay tax, which I think, well, the big idea is, once someone pays, you're able to then use that as proof, as a vote, right? To then engage with policymakers. And
or
part of this
to
is
receive some certain of services.
exactly. Yeah. Proof of it, precisely. Yeah. And so, one of the interesting, as I've kind of broken it down in terms of, how I think it makes. All right, cool, man. Roberto, see ya. How it makes sense to like gradually evolve the thing, is starting with income tax, right? Because that's a lot more frequent, and I'm doing it in the context of the UK tax system. I'm using those variables. So in this particular
I can
context,
make sure I can let me make sure that make sure that you don't need to go with constant. Although the small contract you might save it down. I figured out I can help you on that event. It's okay. I mean, it's no problem. And Janti so the functionality is there already, and you can rely. But just you have to handle the incoming data. So you have to know somehow that data is authentic. You can rely on that.
Yeah. So I mean,
how do you handle that? Well, that's another challenge. Oh, it's off-chain challenge, mostly. But still, about the percent, even you can decide the destiny of that tax. How much percentage of tax should go to this wallet, to this treasury, to this person, to that, even to coming back to that same person. All of this can happen inside a smart contract, without the fixed stuff again.
Fixed stuff, yeah. That's super awesome.
So, but
let's
just
talk
let
about
me sorry, I mean your hands in up and go ahead.
sorry. Yeah. Yeah.
Hey guys, hey, nice to see you. Yeah, I had two quick. I'm at home right now. One of my kids is sick, so
Oh, sorry
there's
to hear
some
that.
music in the background. Yeah, it's kind of like how my life is these days. But I wanted to know two things. What you guys keep mentioning, Iqbal, what is that?
Equival is a project that I'm working with another person that he is also a member of Gimbal Lab, Janti, or his name is Frederick. Equival is a P2P marketplace. So, for example, if you want to send money, let's say you have a cash, you are in you are a resident of US or Canada. I mean, US maybe regulation problem, but let's say the governance is fine. But you want crypto, you want ADA, you want a token, you want NFT, whatever crypto, whatever lives on blockchain, and you don't know that person, second person. So somehow you have to have this deal. So you have to have make this deal happen. So now this comes a smart contract as a smart contract. And Equival is providing these services for people that what we call them maker. Maker are the people that makes the offer. Let's say that I have money, I have cash, I have whatever I create the offer. And taker who is going to get the offer. And then situation upgraded from offer to order. And that happens inside a smart contract now. Offer stuff, advertising is off chain. It's not okay. But when the order happen, when the money come, when the transaction happen, yeah, that should be. And we have already same thing in Bitcoin, in Binance, in other. I mean, P2P, you can search it. You can do it, but it's custodial. For example, in Binance, you have to put money inside your Binance account, and then you do some other stuff off-chain, like sending money through bank or whatever, and then Binance will take the money from your account automatically and charge the person that you send, or the opposite. So Binance is doing that, but what we are designing, that's no, you should do that. You should do that, and again, is a non-custodial. You will be responsible for that, but different situation might happen. Maybe you will put your ADA or NFT or something inside a smart contract. The person doesn't pay. Now what happens? Or maybe he will pay in late. Now what happened? Or maybe he canceled that, although you put your money for 5 days or 10 days there. Now what? That's the challenge, and thankfully we solve most of this issue, and that how we can handle all of these cases inside a smart contract. So Equival is going to provide this service of on-chain validation for transferring value between a person and another person that they do not know each other, and they want to use the trustlessness, permissionless, and technology of blockchain to transfer this. Right now, we are thinking about just fiat and money, and mostly with sub-Saharan African country, which they are using mobile money, but it can be applicable to anything. There is no any room. It's blockchain everywhere, so we can use it. And yeah, that's equivalent.
Okay, cool, very nice. Thanks for the explanation. And how do I? Do you have a website or something?
Yeah, we have. It's not good. I mean, equival.com.
Okay. It's the beginning.
Yeah, it's at the front that they are. It's still they are processing the new year. Some.
Yeah.
Anyway, but I hope that we will launch the app very soon.
Nice. It looks really good.
Oh, great! Thank you.
Yeah.
I'm a person, somehow idealist. One of the maybe big disadvantage of me working on smart contract is being idealist. Like you consider all of these conditions, and that way your front end. That's why I sometimes consider there is something wrong with it. But yeah, thank you for your opinion. And
Yeah.
sure, when we are mainly actually waiting for a stable coin, a reliable stable coin. There are already a stable coin. There are people claiming it's good, but it's not. We investigate that. So after that,
Which one is that?
There is an IUSD from Indigo, and it's not the good that for me. It's
That's
just
synthetic, right?
that, yeah, but it is not even a smart contract. It's not, there is a smart contract, but that's something else. They are handling that stable coin mostly off chain. You don't know anything about that. And at least in our opinion, it's not reliable. I am also part of a stablecoin working group in IOG. We are talking with another project. So there are challenges, there are many stuff, but for a stablecoin right now, Indigo, in my personal, or what we investigate, so maybe you guys know better or more, it's not reliable. And the stablecoin, if we want to implement that in our project, people want to rely on that. People wants to get that, and we don't want to, destroy people's money. And although it's non-custodial, but still. So yeah, I mean, I hope we will launch that soon, and then we will open source the code, both front end and back end, which is a smart contract too. And then I hope I can bring that smart contract to the Bluetooth baseline or this session, and we can discover many stuff that I did there. Yeah.
I know that the JED stablecoin, which is really interesting, it's launching apparently.
Yeah,
in,
but
in
they
like
still
another
are
few
not
weeks or so.
launching. We are waiting. I'm waiting. And
It's supposed to come soon.
yeah, they are very good, well funded. They have very good experience. I mean, their company was involved in crypto for years. And the people inside the company were working in finance, are big company, like even investor, financial companies have people in there. But that's another thing, that's a thing that people like them, they know what they are doing. I know they are what they are doing. Although they are corporate people, they are corporate style, corporate, we don't want corporate, we are centralized, decentralized and stuff. But still, they know what they are doing. They haven't released their stablecoin. But then another project suddenly came, hey, we have a stablecoin, come and use, or just change your dollar, your hard money dollar to or synthetic or whatever we have, and we are giving to you. That's again is concerning to me. And so yeah, I mean, we are waiting for JET, and other stablecoin. Emergo is saying that they are going to share that, but we are mainly focusing on JET. I hope we can trust their code. I mean, they said that they will release their code. I will go through their code and see that what's going on. So yeah, we will see what will happen. But I think
you guys know what JED means?
JET. I mean, I remember that Charles was saying that it is that it means column, and it is column
Stability.
Stability or something in
Stability in
Yeah.
Egyptian.
Yeah,
Yeah.
Egyptian is kind
Yeah.
of. I don't know why.
Stablecoin stability.
I don't know, but why? I don't know why an Israeli guy choose an Egyptian name. That's a question for me. I mean, we have good words. I mean, you are Jewish. We have good words already in Hebrew. I mean, why he didn't choose that? But
I think
also, it's really I mean, it's really hard to. I mean, how can I? I mean, the calling that name, the JET, but there is a D behind that.
it's a bit tricky.
Yeah, it's tricky. I don't know. So
I don't think I forget his name. I don't think it's the Coty guy because Jed came from a paper from IO, right? Coty, that's just one implementation from the paper. So I don't think the naming came
they
from.
could change it. Sure, there's JET and Shen, but
Yeah.
I don't know. There is a Freemason guy in IOG. He's obsessed with this Egyptian symbolic, like choosing Ouroboros. I really don't know, but maybe he there is some guy that he's very simple. He's focused on symbolic stuff.
Yeah.
But
maybe.
still,
Egyptology.
yeah, still, I wish that might be better word. Maybe if someone can pick it up and choose it. But if the IOG was choosing that, okay, then I mean, that they honored IOGs to choose the same name. Okay, I mean, I think they could have even COTI,
I agree.
iCOTI or CUSD, like COTI
Mm.
USD would be
Yeah,
fine.
would it be? Yeah, I agree. Yeah, from a branding standpoint, they're just looking to capitalize on the whole implement, not just the spec, but also they want the implementation to be known as the implementation of the spec, which, I mean,
And we are
anyway,
waiting. By the way, I should tell you that we should see what will happen, because some problem happened with CUSD and Ergo. One attack happened. They survived with cheating the system. I wonder what will happen to Jet. Although they are, again, they know what they are doing. They have good people there, but still, I wonder how can they survive from that. But we will see. So,
And just to
yeah.
answer your question, Mix, real quickly, the Jewish people have lived in Egypt for many years also. So I don't know if there's a connection between maybe some of the Israelis working at Koti, maybe their background, they're Egyptian Jews. I don't know. It's very possible though.
But do they, modern Egyptian, use jet too? Like, is this the word that people use in Egypt, or no? They
I
don't.
don't know, but I Googled Jed because I was very curious, and I saw that there's several people that their first name is Jed, and that it's a quite common symbol in
Egypt.
Egyptology, and yeah, and symbolizing stability, and people wear necklaces with the Jed. So I understand why they would pick the name Jed as a stable coin, meaning stability. But I agree with you guys. When I first saw the name Jed, I was like, what is that? It didn't seem to me like a very strong stable coin like
And I mean, at least in my
USDC or something.
exactly. But it said, in my opinion, when you want to choose your brand or to name, somehow you have to you choose something that you do not need to explain that much. Like, for example, right now, the Coty guy said, "Hey, are you Egyptian company? You use Jet." I said, no, we are not. I mean, okay, so why you choose this? You see, he has to go to all the explanation. Why did you choose this name and that? So I don't know,
Koti makes
maybe.
sense. It's coin of the internet.
Exactly, Coty
That's
and
beautiful.
CUSD would be, I think, would be awesome. That coin of internet USD. That's all. But anyway, maybe we will do it by ourselves. Do you have any idea for creating a stable coin project? Just let me know, and we will create a better name for that.
Yeah. That's one of my
Yeah.
strengths is with words and writing and
If you are interested, really, so then join us on the working group. We have several working group IOG. Not many things there is just developing and many things, especially about regulation, law, about how to handle it. Was this thinking, is a brainstorm. So if you are interested, look up for IOG working group. There are several working group. One of them is a stable coin. Each 2 weeks we will gather and talk about that. There is for certifying working group, developer experience working group, and interoperability working group. So if you're
is it through
interested,
Discord or where do you find it?
yeah, I mean, do you have? Can you give me your Discord ID? I
Yeah,
can
of course.
but in IOG website, the official, I think you can find the link to the working, and then they will give you the invite for Discord, and then based on the survey you did inside the website and the role do you want, work in which working group, they will assign that role, and you can see what's going on with that specific channel and working group. So
Cool.
inside the main website, yeah, you can do it, but sure, you can hit me. And this is my idea. I'm going to share it on chat too.
Okay, I just sent you my Discord. It's Happy Man
Oh,
7681.
okay. So okay, I will search that. Okay, Happy
Yeah.
Man. Yeah, I choose the happy
Yeah.
token too.
Yeah. I strongly believe that if people try to find their own personal happiness, that it spreads and make the world a better place. And I'm not always happy, of course, but like it's one of my goals to try to do things that make me happy and to
You know,
make
in
other
some
people happy
analogy,
too.
some people say actually, if you become always happy, you will become senseless to happiness. So somehow suffering is going to give meaning to happiness.
Totally.
I agree. Mm,
So yeah,
yeah.
guys, if you
It's
guys
been
agree,
like close to 3 hours or something.
yeah, let's
now.
wrap it up. And
Yeah.
also people are seeing and sharing on in YouTube too.
Yeah,
So
live.
yeah,
All right, cool, man.
thank you for your time. And again, if you have any question, please let me. I don't have my Discord right now, so I will DM you or if you have question or something. And sure, let's
All right.
continue about this. Great. Take care, guys.
Indeed.
And
Take care.
see
Thank you.
soon. Bye bye.
Bye.